Consensus is one of the hardest problems in computer science. Imagine 5 servers that all store the same data. If one server receives a write and another server crashes at the same time, how do all the machines agree on what the correct state should be? Without agreement, replicas eventually diverge and your distributed system becomes inconsistent. Raft solves this problem by introducing a simple idea. At any moment, one server is the leader and everyone else is a follower. Clients never write directly to followers. Every write goes through the leader, which becomes the single source of truth for coordinating changes across the cluster. The leader stores every change in an ordered log, but writing locally isn't enough. The leader must replicate that log entry to the followers. Each follower appends the entry to its own log and sends an acknowledgement back to the leader. Here's the critical part. A log entry isn't considered committed when every server receives it. It's committed when a majority of servers receive it. In a 5-node cluster, that means this majority requirement is what allows Raft to tolerate failures while still preserving correctness. But what happens if the leader crashes? Followers expect to hear periodic heartbeats from the leader. If those heartbeats stop arriving, the followers assume the leader is dead. They start an election by increasing a term number and requesting votes from the other servers. The first server to receive votes from a majority becomes the new leader. Because only one server can obtain a majority in a given term, Raft guarantees that there is never more than one active leader at the same time. The new leader then resumes replicating log entries as if nothing happened. The reason majorities matter becomes clear during network failures. Imagine a 5-node cluster split into groups of 3 and 2. Only the group with 3 nodes can form a majority and elect a leader. The smaller partition cannot make progress, which prevents 2 leaders from making conflicting decisions. This combination of leader election, log replication, and majority voting is why systems like etcd, console, and Kubernetes rely on Raft. The algorithm turns a collection of unreliable machines into a system that can agree on a single history of events, even when servers crash or networks fail.